So I am using a new program, so bear with me if this comes across a little weird, but we're going to be learning about prime and composite numbers, and the first thing we need to do is understand what a factor pair is. And if you can see right here, here's the definition. A factor pair for a number is two whole numbers whose product is that number. For example, 2 and 5 is a factor pair for 10. So let's think of all the ways that we can get to 12 with factor pairs. The first one is an array. 1 and 12 is a factor pair. Another one we know is 2 times 6 and 3 times 4. And those arrays would look something like this. It's not perfect, but so you can kind of see what factor pairs might look like. So if I were to write out the factor pairs or list the factor pairs for 12, it would be 1, 12, 2, 6, 3, and 4. But we normally would like to list them in numerical order. That's the best way to do it. So if I were doing it, it would be 1, 2, 3, 4, 6, and 12. And we're talking about the pairs. 1 and 12 are a pair, 2 and 6 are a pair, and 3 and 4 are a pair. So if we're using these tables down here to find all of the factor pairs for each number, we would need to work it out. And I always just go 1, 2, 3, 4, 5 and think of what it would be divided by. So 32 divided by 2. If you weren't sure, you could do this, right? If you absolutely didn't know the multiplication fact off the top of your head, you could just do your basic division and know that the factor pair for 32 would be 2 and 16. Now 3 does not go into 32, but I know that 4 does. So 4 and 8. 5 does not go into 32. 6 does not go into 32. 7 doesn't go into 32, but 8 does, and we already have that other pair. So we're finished and done right there. If I were to move into 44, I would do the same thing. So I know that 2 goes into 44 22 times. 3 doesn't go in it, but I know that 4 goes into 44 11 times. And I know that that's probably the last one, because 5 doesn't go into it, 6 doesn't go into it, 7 doesn't go into it, 8 doesn't go into 44, 9 doesn't go into 44, 10 doesn't go into 44, but 11 does, and I'm already there, so I know I can stop at that point. With 100, I know 2 goes into 100 50 times. I know 4 goes into it 25 times. I know 5 goes into it 20 times. And 10 goes into it 10 times. So these numbers are all factor pairs for the number at the top. Now it's asking us to list the factor pairs for each of these numbers, 29 and 63. Well, let's think really hard about 29. We definitely know that 1 and 29 are factor pairs, but it's not even, so 2 and 4 and 6 and 8 aren't going to go into it. It doesn't end with a 0 or a 5, So 5 and 10 aren't going to go into it. So I think 1 and 29 are the only factor pairs for 29. I also know that 163, 7, and 9 go into 63. But I also see that there's a 3 in there, so I think 3 goes into it. So I'm going to test it to 21. So 3 and 21. Okay, so I'm hoping that you're starting to see a little bit about, understand a little bit about factor pairs, because now we're going to talk about actual prime and composite definitions. So you can write this in your notebook, or you can just circle it in on your page, but notebook would probably be better so that you have this to refer to when you need to. But a prime number is a number greater than 1 that has 1 and itself as its only factor pair. Some of the prime numbers are 2, 5, 11, and 23, and we just witnessed the number 29 on 160. A composite number is a number greater than 1 that has more than 1, and some of the examples are 4, 12, and 25. Now, something to know that's very important is that the number 1 is neither prime nor composite. So, right here, we're going to talk about the number 24. Let's think of all the multiplication problems that there are for 24, or the factor pairs. We know 1 and 24. We know 2 and 12. We know 3 and 8. We know 4 and 6. And no 7 and 8 we've already said, so we'll stop right there. Well, we can see that there's 4 sets of factor pairs. So we know that 24 is a composite number. And if I was explaining my answer, it would be because there are 6 factor pairs or more than one set of factor pairs. So when you're trying to identify prime and composite numbers, it's really important to know your multiplication facts. So if you're struggling with those multiplication facts, you might want to have your multiplication fact table next to you so that you can see those multiplication facts in front of your face. So we're just going to be writing prime or composite on these numbers here on the bottom. 99. So we need to just think 1 and 99. I know of another multiplication fact real quick, 9 and 11. So automatically I know that this is composite. I'm going to make my way down the columns here. So 45, I know 1 and 45, but I also know off the top of my head 9 times 5 is 45. So automatically that has more than one factor pair. So this number is going to be composite. 67. I only know of 1 and 67. 2 doesn't go into that number. 3 doesn't go into that number. 4 doesn't go into that number. So I'm really thinking that 67 is prime. I can always check myself and look on my multiplication table if I'm unsure. If you find any other multiplication problems between 1 and 67, then you know that that number is prime. 72. I know that one's composite right off the bat because I know 9 times 8 is 72, and that already takes it above the 1 and itself. 19 is prime. 100, oh, we made a whole list of factor pairs on the first page, so we know that this one is composite. 31 is prime. 88, I know 1 and 88, 2 and 44, so I automatically know that that's composite. 53 is prime. 1 and 53 are the only factor pairs. Is 2 the only even prime number? I'm going to let you think about that for a second. Yes, 2 is the only prime number, and the way to explain that is that, yes, because all of the other even numbers have 2 as its factor. Prime and composite numbers are all about the factors. Now we're going to talk about how factors and multiples are related. A multiple of a number is its product, or the answer to the multiplication problem. So what are the first 5 multiples of 4? So 4 times 1 equals 4. 4 times 2 equals 8. 4 times 3 equals 12. 4 times 4 equals 16. 4 times 5 equals 20. So all of these numbers right here are multiples of 4. The way I would explain my answer on that is by simply writing the multiplication problems that we said. 4 times 1 equals 4. 4 times 2 equals 8, etc. So the first 10 multiples of 8 would be 8, 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6, 8 times 7, 8 times 8, 8 times 9, and 8 times 10. Okay, are you starting to get it? So is 54 a multiple of 6? Why, yes. Yes, it is. Because 6 times 9 equals 54. And we know that 54 is a multiple of 6. Is 6 a factor of 40? No, because we know our multiplication facts, and when we skip count by 6s, we don't ever say the number 40. What are the first 5 multiples of 9? Well, and my method is going to be to skip count by 9s. 9, 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45. I skip counted by 9s. That's my explanation of my answer. What are the factors of 63? So 63, it would be 1, 3, 7, 9, 21, 63, which we already kind of did those on that very first page. Is 63 a multiple of each factor that you listed for exercise for number 25? Is 63 a multiple of those? Well, yes, of course it is, because it is the answer to each one of those pairs. So, for example, yes, because 1 times 63 equals 63. And 3 times 21 equals 63. So we know that 63 is a multiple of each of these factors because it's able to be multiplied by something else to equal 63. 7 times 9 equals 63. And that's it, those 3 pairs. So what we're going to practice tomorrow is we're going to be looking at more multiples, prime numbers, and composite numbers. And so this was just supposed to give you a little preview to what we're going to be working on more, and hopefully you'll get a better understanding of it when we play with it a little bit more.